Okay, guys, let's now turn to Excel, and I'll use the Data Analysis Toolpak to generate 100 samples of size 25, and the values will be selected from a normal distribution with a mean of 368 and a sigma of 15. So let me share my screen there. Okay, so I already have my Excel open for me here. So what I'm going to do is I'm going to choose the data analysis option. And there are various alternatives here you can choose from. And we did this last semester. You probably remember that. So, and what I'm going to choose is here below moving average, the random number generation. Okay, so let's choose that. So number of variables, what it's asking is basically number of samples. So I'm going to specify as 100. Okay, the number of random numbers, that's the rows, that's the number of the sample size in each sample. And I'm going to let it come from a normal distribution with a mean of 368 and the standard deviation of 15 specified there. Now, since there's a random number generator here, you can choose to specify your own seed, or Excel will take a seed from the computer. So let's just say okay here. And now we've got a huge bunch of, it's a total of 2,500 numbers, okay, arranged like this. So let's suppose this is my first sample, this is my second, and so on. So let me just take here the average of the first sample, okay, and this must be A1 to A25. Okay, correctly stated like that. So then what I'll do is actually, now this is a sample that I took, and if I want to compute a confidence interval and knowing the sigma is 15, okay, I could do the following. So let's choose the lower confidence limit first, minus 1.96 times 15 divided by square root of 25, which is my sample size. And then I'll actually use the upper confidence limit here, plus 1.96 times 15 divided by square root of 25. So now we see that this first, at least for the first sample, the calculated confidence interval actually includes the unknown, but true population mean. So now I'm going to actually carry it over to the remaining samples. But also what I want to do here is I want to put the actual correct value just so I can actually graphically show this to you. So this is the correct value. This is the lower confidence limit, upper confidence limit, and this is my mean of the sample. So now let me just carry it over to the remainder. Okay, so let's just okay, so which is something I didn't want to happen, but it, okay, I don't want that. I want that to be a constant. So let's just do that one more time. Okay, because it automatically increased it by 1. Okay, so that's good. So just so we see this graphically, I want to do this. I want to do a graph, and I want to show you basically which ones, okay, which ones. Okay, I think it's pretty clear here. So this purple line is the actual population mean, and the blue line is the sample averages of the different samples that I took. And overall, I took 100 samples. So the yellow line, the upper confidence limit, and the red line, lower confidence limit. So the width of this yellow, green and red is actually constant because I'm using a known sample variance. So the right part of the confidence interval formula, okay, sigma divided by square root of n times 1.96 remains constant. Only if I increase my confidence level, this difference between the red and the green will actually increase. So let's see if any of these intervals, upper and lower, they generally include the purple, except there's one here, obviously, that doesn't include. Okay, and there may be another one here that doesn't include. Okay, so the real population mean is outside. So from the graph, it's hard to see, but let's get rid of that and let's try to see how many actual samples did not contain the true population mean. So I'm just going to put in here a small if statement. Okay, so the confidence interval doesn't contain the true mean. So if the lower confidence limit is actually greater than the true value, okay, so that doesn't include the population mean, obviously. Or if the upper confidence is actually smaller than the true value, again, we have the confidence interval not including the population mean. So for the first sample, clearly the true population mean is in this interval, 366 to 378. So this is 0. So let's actually take that all the way to the right. Okay, so how many samples do I have such that the confidence interval does not include the true population mean? So I can just add these values up, and I think it's CV 32. And if I do that, and now it's 3. It's very interesting. So it's less than 5% even. So in the example I did just 10 minutes ago, it was 6. So this is going to change. I mean, 95% is not a fixed value, but it's going to be close. And approximately 5% of the confidence intervals will not include the true population mean.